All right, so please sit back down. So, I hope you had a fulfilling lunch. And now you're ready to keep on discussing SDMX, and in particular, data modeling and semantic versioning. This session will be co-chaired by Yamil Vargas from the IMF and by Glenn Tice from the BIS. We have until 4:30, and this will be the last session of the day. At 4:30, we should have a coffee that you're welcome to take, but then you're free to go your own way until the dinner, for those of you who want to come to the dinner. And I will give a bit more information about the dinner, the location, at the end of the session, so don't leave too early, okay? Len, Yamil, the floor is yours.
Okay, thank you, Luca. So Luca wished that you have a fulfilling lunch. I wish that you had coffee, so to stay awake during the whole session, because we have an interesting lineup of presentations in which presenters will show new developments in tools to assist with data modeling. There will be also a presentation looking into the task of identifying statistical concepts, which is an essential part of data modeling. And also we will see the progress made by the joint SWG-TWG task force on semantic versioning. As Luca said, my name is Yamil Vargas. I'm a data management officer at the International Monetary Fund and deputy chair of the SDMX Statistical Working Group. Good afternoon and welcome to the session. I will be co-chairing this session with Glenn Tice, who will introduce himself.
Thank you, Yamil. So yes, I just echo what Yamil said. I think this is really exciting session. We've got four, really quite interesting presentations, quite diverse presentations as well on the topic of data modeling, which has already come up several times in previous sessions and previous presentations. But for me, I mean, data modeling is really key. I mean, it's the cornerstone of SDMX. You really can't do very much without modeling your data first, right? So data modeling is really key, and I think we're going to have a really exciting session. So yes, as already introduced, my name is Glenn Tice at the BIS, working on the SDMX Tools program mainly. So with no further ado, I think we should probably move straight into the first presentation, which is to an extent a follow-on from the very first session that we had on Monday to do with AI. And again, very pleased to introduce Jeff Danforth and Maxim Sambusenka, who will present on AI-powered SDMX data modeling tool. I'm not going to reintroduce you because we have already introduced in the first session. Thanks very much. Over to you.
All right, good afternoon, everyone. Really quick agenda, and I kind of have the easy part. I'm going to provide some background, a bit of the problem statement, sort of how we got here, and it does follow on exactly from the discussion yesterday. So some of the data sets that EPAM worked on to ingest for the back end of StatGPT didn't have SDMX API endpoints. So they were faced with the problem of creating sort of SDMX artifacts and doing the modeling piece, and they discovered something that maybe we all know, which is that that's kind of hard, and it's not necessarily easy to do the modeling, it's not necessarily easy to assign SDMX artifacts. So as they were going through that problem, they thought, wouldn't it be nice to have a tool that could help with this? Of course, there are lots of tools out there that convert CSV files into SDMX compliant artifacts, but sort of following on this idea from yesterday on the dissemination side, there may be a new way in which users are going to sort of access systems to help with all sorts of things, and that might be conversational-based interactions, much like you would see in sort of ChatGPT, but sort of this utilization of large language models more generally. So this sort of demonstration that Maxim's going to take you through is really that. Can you have a kind of conversational data modeling, entity or copilot? And we actually don't really know if this is a good idea or we should keep sort of pursuing this. So I think that's one of the main questions for this group. Is this a good start? Should we keep going? Is this a waste of time? So Maxim, take it away.
Yeah, thank you. Okay, so the problem that we were facing, it was, I'll probably switch it to the presentation so that you have it. Okay. It's much simpler, and I set a clear expectation here than you usually, or this community usually solves. So we did not need to do any type of harmonization in our work. We just had to actually do a very simple thing. We essentially had an Excel file, and then with some data in it, and we wanted to create an SDMX data set, which is, as many of you might know, is a journey. You might use some tooling, SDMX converter probably could help, but still this, if you are very used to this task, it would probably take you a day or several hours just to complete it. So we decided to take a look whether GenAI actually could help this part as well, because all our previous attention was solely on the retrieval part, on how we can find the data, the indicators that we publish. But can we actually do something for the people who work with data modeling? And the idea was to, I believe many in this audience are familiar with the concept of Copilot. Microsoft did it quite well. This is something that is embedded into your tool, and it improves your probability. And it is enabled with the context of your work, of your documents with which you're manipulating. So can we provide something similar to the tasks of data modeling? And we decided, we made several key principles for ourselves for our research, how we actually approach this. So first we say, okay, we want GenAI to actually help us to do these monotonous tasks. We wanted to instruct it to act like a human, like how do we actually approach the problem and how we do this kind of model in our heads. I'll talk a bit about this later. And we still want every action to be validated by the human. We still do not trust this thing to the extent that we are ready to publish everything that GenAI generates just out of the box. We still have a human in the control, but we want to remove a lot of complexity from his daily operation. And now I'll show you the demonstration. So this is the file. Quite simple one, not exactly the one that we've been ingesting, but it gives some idea of how we define the problem here. So first column here is geography. Geography, it's AK, AL. I can guess that this might be some states within the United States. Then indicators, they are pretty straightforward. They'll have these underscores in them, unit of measure, scale, with literally multipliers, time periods, frequency value. Quite a simple structure. So what we did, I'll show you the demonstration of the application for the sake of time in the replay, in the playback mode. It's just, I'm running some conversation that I had previously with the system. So I'm attaching this file and I'm asking the system, please generate a blueprint of structures for it. After some thinking, it makes quite reasonable modeling. So it says, okay, your dimensions are geography, indicator, time period, and frequency. Your measure would be value, and your attributes would be unit of measure and scale. It also makes the decisions that, okay, probably I classified that geography, indicator, unit of measure, and frequency would be code lists. And Then for the others, I would identify the types that time period is a special time, observational time period. Value would be decimal, scale is integer. If I look under the hood for this operation, I'll give you just the approach for the thought process. And this is the thought process that is implemented by LLM. So it first tries, like it first identifies several dimensions and validates the hypothesis that whether they would make the unique combinations, whether they would not have duplicates there. So it tries to do it in the following way. It first identifies their candidates, its candidates, geography, indicator, unit of measure, time periods, and frequency. It checks those and it says, yes, this is the valid combination of dimensions. No duplicates. We get no duplicates with this combination. But can we reduce it? Can we actually make the set of dimensions smaller? So it tries with the second attempt. It understands that probably the unit of measure would be the candidate for removal. So it tries another iteration and says, okay, I'll try geography, indicator, time period, and frequency. This is also a valid combination on this data set, so we reduced the number of the dimensionality of this data set. Then it performs another iteration. It tries to remove indicator. At that point, it understands that actually we already get conflict, so we cannot actually remove the indicator. At this point in time, the algorithm stops. And we have identified quite a nice structure for our data set. But what if, whether unit of measure and scale are dimensions or attributes? This is not clear. They might be as well attributes and dimensions. So this time the system classified them as attributes, but what if we want to change this? Then I simply say, please move, well, I didn't say please, which was impolite. I say, please move the unit of measure to dimensions. And this was executed. So now I'm kind of in control of what I will get as the result in the end. So still it gives me the new blueprint with everything like these are dimensions, measures, attributes, and these are the types that I'm going to generate. And then I just say, okay, create the structures. I want the structures to be created. What happens here is this is the integration with the API of the system that actually handles all the data modeling operations. So it's not purely communication to the chat, but we are really generating the structures. I'll show this by simply clicking on some of them, which might be interesting. So I first start with code lists. So this is frequency. We had just one value for it. What's important? Let me bring you the original file back. I only had the Q here. I didn't have any any column that was saying quarterly. Here I get the name. Why? GenAI GPT-4 generated it for me. Then geography. This is probably the most interesting. Again, no instructions were made to identify that those are the states. I didn't do this. However, the LLM, from the Python, it's understood that this my idea was right, that this might be the names of the states. So it generated the names already. Important point here is that we do everything in drafts, so we still assume that there might be some manual work to look through this and maybe change to what we actually need. But at least we get a lot of work done just out of the box and very quickly. Same goes for indicators. Here the system identified these underscores and provide me with meaningful names. They would essentially repeat what I have here, but with proper capital case usage and with proper space usage. And the same for unit of measure. I also get handy I also get handy concept scheme. So this is the list of concepts with all appropriate types. So some would be bound to code lists, some would be bound to particular integer, decimal, observation time period data types. And I have the data structure. Again, very well to what I would have expected. So I have one measure with value, a list of dimensions. It have taken my ask to move unit of measure here to the dimension, and a scale as an observation level attribute. So this is what we achieved, but we probably don't want to stop right here. And I would like to talk to you on the last slides about what happens next and what can we do to move this initiative forward. So first point is that we really want, so for us this was, we came out from the problem that we had and we wanted to solve, which we did to our benefit, but we don't want this to be purely IT thing. We really want to focus on the problems that real people who work on the data model and have with it. So we identified some, and we are still in this stage where we actually look for the use cases and for how this could be, and whether it's actually, there is an interest for it, and whether it could be, like anything could be added to this to make it literally useful within the community. So we have identified several things that we want to try ourselves to make it probably even more interesting and demonstrable. Still, we will be looking for feedback. I'll talk about it a bit later. So first, the usability use case. In my problem definition, I defined that I want this to be a co-pilot-like experience. However, what I have been showing to you was integrated but I was talking in a separate chat. So first and quite evident point would be to really integrate this chat into the data management studio and make it context aware. So if I open some of the code lists, then it would know from the context that I am talking or changing this particular code list. So I do not need to send the names or the IDs. Apologies. Then several productivity use cases. So what if I'm not generating new structures, but what if I already have a structure and what I want to change it? I give here some examples. It would be quite simple for us to support. I'm standing inside the concept scheme and I say, okay, please add a concept scale with default representation to CL scale. Or I'm standing inside in the DSD and I say, please, I have an attribute called unit with ID unit. It is data set level and I want it to be time series level because I need to make this change. Or I'm standing on the listing of all code lists and I say, okay, please generate me the list of countries, use ISO 3 code as an ID for this, and use name as the value as the name for it, and generate descriptions of 3 of 10 words long maximum. This probably is not the very best case for this particular community, just because a lot of investment have been done into the country's code list, but this is quite nice. I mean, to give if we just need to give the idea, if we need some new code list, then we can instruct it where to take parts and components for it. And one more use case we received from our colleagues from the IMF, and we actually faced it ourselves when we've been doing data modeling exercise with the national agencies. Many of you might probably know this case. So assume there is a lot of statistical data produced by some agency, and I've seen it several times that this would be an Excel with tabs in it, and each tab would be representing some slice. All of this is good and meaningful data, and now we need to create an SDMX data set out of it. How do we do that? Because there might be very different. I mean, if we just go mechanically, we might end up with, I don't know, 50 dimensions representing all those slides, and a very sparse data set in the end. So this is the challenge, and this is what the directions that we actually want to explore more. Here, I would really like there is my email there. So if you believe that you're interested in this use case and just want to get updates, so please send me a note, and I will also, you received this paper with the participant list. I'm in Poland, so look for Poland. My email is listed there as well. Or if you feel that you can, or you want to add something to those use cases that we have put to the slides, then please send me a message. We're really still trying to understand whether this is worth exploring, whether this is interesting for the audience to use the Gen AI for data modeling problems. And this concludes my presentation. Thank you very much. And apologies, one more important notice. I will not be able to stay here until the end of this session. So if you have questions, then please ask me now.
Yes, please. Let's go with Stratos first, please.
Thank you. This was really interesting, and I just have I have many questions, but just one of them is about the integration. So, what is the current state? Is it something that would be able to communicate with any, for example, SDMX web service to make this integration, to realize this integration? And that's all for me.
Okay. Thank you for the question. I already disconnected my laptop, so I will not be able to show you the. So what the system is doing is it generates the code, which is the SDMX compliance. On the get parts, this is like, since the get is the standards, it is like clearly compliance. Then with the submission, with the post parts, well. I believe there could be some level of abstraction, or if it becomes a standard, then it also will be. So all the communication with the system is done via API, and this is the SDMX-based API.
Yes, Jonathan.
So thank you for this. Really interesting to see this, because we discussed this many times, and I think over the last days you've seen the need for simplification as well. So that said, it's still, it's early days, so it's still far from being a sort of extraction of the data modeling that could really serve the purpose of like low capacity countries, to really do this. And yes, I'm just wondering, because I saw, there was many sort of concepts you have to understand, what is an attribute, for example. So I'm wondering, is there any thought or way to integrate things like references to existing structures like global DSDs, or even the modeling guidelines and things like this, to have some basis to start with, rather than having to really think that through as a data model?
Great question indeed. This is a very a very good task for LLM. So this is not a part of our prototype. And again, I kind of invite you to this virtual working group. I'm still not sure what the format it would be, but I at least would like to know people who are interested in this case. Assume that you have a problem, that you are not creating the structures in the green fields, but you already have quite a lot of structures. So probably for the geography, I would want to check whether I have this code list already. And if I do, then is it okay to proceed with this one? Or do I need to update it to create a new version? LLM could clearly help with it. This is a good task for LLM to find this similarity and to find whether this is the appropriate code list and to check whether we can reuse it. This is a good case, and this is a good use case for the list of the use cases.
Yes, 2 questions in the middle. I think you were first.
So thank you for your presentation, and I think one of the questions that I raised yesterday, we can find the part of the answer here, that how to streamline or automate or to make easy data modeling. So just for this stage, and I want to ask about some few technical points. If I understand well, if you have a column when you have a code, so the system will try to find which label, and then it will give you the code list. But what happens when we have the code and the label in separate columns, if the system can deal? And the last question, I have a lot of questions, but let me summarize. If there is some non-accepted characters like dot or space, for example, this CSV is well designed because more or less easy to transform it in SMX format. But what about if the code there is a dot or a space, the system will be able to detect and correct or not? Thank you.
I'll probably respond very similarly. So just write me an email. So this is a good use case. Clearly can be addressed. So currently, there is no system. This is a prototype that does a job, and for us, this is just the beginning of the journey and beginning of this conversation or initiation of it. What I really my major goal here is to have this ideation thing that we all come together with how it can be actually and whether it is actually can be useful. So I feel interest, which is great. So Bryce, whenever you feel that something could be a good use case for it, just write me an email.
Just one question, and congratulations, because this is not the Holy Grail, but it's a nice class, honestly. So I think we are in a very good way. When you decide the measure, is that based on that is a continuous variable, or how? Because I missed that part. I don't know if you explained that. Because you recognize the dimensions and then you recognize the measure. So that is one question. Thinking of the multiple measures and how to, if it is possible, to identify that from attributes. And the second point is a suggestion. I think that ingesting Excel tables, multidimensional tables, would be a good next approach, because in our experience is what is most commonly given as input, rather than CSVs, flat CSVs.
Okay, so, CSV Excel is just the matter of formats. It's very simple.
No, not the format only. The multidimensional table that is used for publication. Okay. It's not a flat CSV or a flat Excel file, but a table that has dimensions in headers of columns and header of rows.
Right. So for the Excel parts, again, sky is the limit with respect. I mean, we have seen the Excels which would be quite complicated to analyze, like a balance with left and right sides. So very it would not even be a table. It would be something very very particular to the use case. So whether we want this particular use case to be handled by the system, it's just a matter of investment. Whether we want to only solve the 80-20, like 80 of the majority cases, or whether we want this bar to be at 95 or 100% of cases win. Apologies, I probably missed the first one. Could you please?
Yeah, how you identify the measure?
Okay, right. So what's so this goes to the prompt engineering, which we're using here. The instruction. So I will give you the spirit of it, like not the particular prompt, but it says, okay, this is the list of columns which might have like attributes, measures, and dimensions, and we would probably expect that something that is that dimensions would contain at minimum frequency, time periods, indicator, and country. And we would also assume that usually dimensions would be, we probably assume that they would be code lists and not the numerical ones, and there should be at least one measure, and this measure is probably a value. Right? So then the rest of the job, and we give the sample of this data to the LLM so that it knows the sample and it can analyze everything that's in this sample. Then it's LLM's decision, which, as I demonstrated, is quite, at least on this particular file, is quite reasonable. And then we still have a person in control where I can do this. So if something was identified as an attribute, but I want this to be a measure, this is disputable, like no right or wrong answer here, I would just send the prompt and say, please move it from here to there.
Thank you. Any more questions? 1, 2.
Okay. Yeah, it was not so much a question, it was more like a comment or observation. I mean, are we sort of shifting the capacity gaps from like data modeling now to prompt engineering? I mean, it's just a thought. So how much effort is involved in one versus the other?
I do not have enough data to compare. I mean, we like the prompt engineering here is quite simple, as long as we like. But when we start adding new use cases, it might become way more complex. But there is another part of this equation: is how much time do we invest into classical data modeling? And here, I mean, I would really need the help of the community to actually measure. Okay, we invested this much, or we believe that this much can be invested into solving this with AI, and this much is invested into. So this is the preparation of the business case for us. And if we identify that our resources could be spent more reasonably than just trying to evaluate this path, this is also a result of this conversation. So I'm just like throwing a ball at you and just want to see whether you catch it and we carry forward together.
Thank you. One more.
Thank you. Yeah, I understand this is proof of the concept, but for this you use like the target is SDMX 2.1 or 3 or version 3, because like related to the input, I agree for the output data, the kind of quite common definition is like already semi-modeled example in Excel, but for the modeling microdata, yeah, the CSV is kind of perfect source, because usually people store this kind of data sets in CSV format.
I'm using a particular system with which I integrate, which we implemented actually with the IMF. This is the new IMF data production system. So it is IMF Data Studio. It supports 3.0, and of course we are utilizing everything that 3.0 gives us. So these drafts, this semantics version, and it is all there. We are using it. However, there is no strict limitation. So that this should be only the platform that supports 3.0.
Thank you. Any more questions? I see none. So maybe I close just with one from me then, perhaps, before I let you go, Maxim. I know you need to get off. The dimensions must form a unique series key to be valid, for the data to be valid. Does it take account of this already, or do you perhaps foresee that analysis to make sure that the dimensions that are selected are indeed a unique series key, perhaps for the data set which has been ingested?
This is implemented already. So this process that I've been showing to you, it's exactly this process. So we LLM makes some assumption, and first assumption is wrong. It adds the unit of measure to the dimensions. It checks it, identifies that those are unique, and then it tries to remove, and then tries to minimize this set of dimensions. And then it ends up with the expected set of dimensions. Right? And we are really validating it on the data set. It's quite small, probably for the 1-2 gigabyte data sets, we would want to validate it only on some sample, but here we validate and then we make this decision based on data.
Perfect, thank you. So unless there's anything else on this topic, I see no hands. So in that case, Maxim, Jeff, thank you very much indeed.
Thank you.
Okay, very good. Good way to start this session. Now, Glenn is going to switch hats and is going to present the FMR data modeler user interface. So Glenn, over to you.
Thank you. Do we have the presentation? Perfect. That's the right one. So down a bit. Good. Yes. So second presentation. So the AI, fantastic. I mean, real innovation. I think this is for me. This is the first time I've actually sort of seen this sort of thing in practice. So really well received. But generally, data modeling is tough, right? Most of us agree this, and I think data modeling within the SDMX space is doubly tough, because not only do users need to know data modeling craft, but they also need to understand SDMX. They also need to understand the SDMX information model, which we know is not a particularly easy feat. For anyone, but obviously, experienced statisticians know what they're doing, but may not be particularly experienced within SDMX or such. So tools like the AI are potentially going to be sort of really, really beneficial in this in the future. But today, what I want to introduce is a project that may sort of help ease some of this a bit by combining the principles of the OEC's very well-established matrix generator tool with Fusion Metadata Registry, which we've also already sort of seen in a couple of sort of previous presentations. So what's the context? Well, the context is of course statistical domain modeling specifically as such. So statistical domain modeling, generally well established. There is some SWG guidance, which I think many will be familiar with if you're not. It's on sdmx.org. I think it's been in place for sort of many years now, and it's actually really sort of proven the test of time. But the challenges here, so the challenges particularly, I think, as I understand them, and please forgive me, I'm not a statistician, I'm a computer scientist, so please forgive me my statistical knowledge on this, but the people who are obviously explain that the challenge of building statistical domain models is to build and maintain these sort of cohesive models, and of course to build them using the collection of SDMX artifacts we have. And as I say, the statisticians generally know what they're doing. They know how to model domains, but obviously may not be 100% experienced with actually doing that in SDMX. So a solution is tooling, and tooling that really does two things. One which sort of follows the guidance that we have, which is sort of well established. It's been proven time and time again. So, there's no question there. And hopefully also, to some extent, insulates the users from some of the idiosyncrasies of SDMX. Obviously, you're not going to sort of get rid of those completely. So, just a little recap. Specifically about the SWG's modelling guidance. If you really haven't sort of come across this before, I really recommend it's as a read. But one of the key points here, which we'll sort of touch on a little bit later, is that it centres on, in the guidance, certainly what's called the DSD matrix. And again, if you're a user or seen the OECD's matrix generator, you'll be very familiar with this. But for me, this is an abstract data model. It's nothing to do with SDMX. It could actually be applied to sort of many different domains. But it's really nice because it allows the statistical domains to be modelled in an abstract way, and then of course converted or materialised in some way into the actual SDMX artifacts that we know. And in addition, it takes account of the need that when you are modelling, or particularly when you're remodelling, the need to perhaps decompose compound indicators into more granular indicators. And I'm not going to go into any more detail on this at all, because Alan will update us on that, I think, Yavush will update us on this in the next presentation as such. But finally as well, there's well understood ways of actually sort of optimizing the models as well. And so really great guidance, well established workflow. But of course it's a document, it's a PDF, it doesn't really help us particularly much. So some tooling would be really nice for that. And there is. So obviously in the beginning there wasn't any tooling. There was the guidance. I believe there was an Excel spreadsheet which helped to put this together, but it was just an Excel spreadsheet. A useful tool in its own right, but you then still had to take that and actually translate it into SDMX artifacts, which was a real pain. Then came along the OECD's matrix generator, which was revolutionary in that respect, because it took that whole Excel model and actually automated that. So added some logic, added all of the process behind there. And I think as was demonstrated earlier, actually you can build a whole model, build a whole abstract model actually in the worksheet, press a button, generate the artifacts. There it is, brilliant. You don't have to mess around with creating concepts and code lists and DSDs and all of that sort of thing. It's all done for you. However, it's still disconnected, at least to a large extent, from your target registry. And of course, for institutions who are sort of working with registry tools like FMR or even other tools, where you want to create these artifacts and then obviously sort of manage them, and they have a life within the registry, then there's another step, obviously, where you have to take those artifacts and physically transfer them to your registry. So here's the vision. Fusion Metadata Registry Data Modeling User Interface. So an evolution, very much an evolution of the OECD's matrix generator, using pretty much the same principles. We'll look at that in a little bit more detail, but critically now a web user interface. So no longer a spreadsheet, but a web user interface that could be can be published on the web and intranet. Could even be connected to the global registry if you wanted to, or something like that. But critically as well, completely integrated with the target metadata repository. So currently, Press Generate produces some files with some artifacts in it. What's perceived here is that you develop your DSD matrix as the abstract model, press commit, bang, straight into the registry. Simplifies the workflow. So, just to be a little bit more specific as such. So we've seen Fusion Metadata Registry. If you're a user, then you will know that it has a built-in user interface. We saw it in action, actually, in Jose's very nice video earlier, as such. And it's got a user interface for maintaining and creating artifacts, and that's great. And that works really well for certain use cases, and particularly for things like structured browsing. You want to know what code list you've got the complete list of code lists. You want to retrieve some structures. You want to retrieve the DSD. You want to get the code list. Works really well for that. Ad hoc creation and maintenance, we all need to sort of periodically add codes to a code list, or sort of ad hoc maintenance. So it works really well for those administrative tasks, those sort of browsing tasks and everything. But where it really doesn't work is this domain modeling workflow, which has a very specific workflow. It's not that you cannot do it in FMR's user interface. Indeed, you can, but you have to go through this process of conceptualizing your abstract model and then converting it into the individual artifacts, and then theoretically creating it. Obviously, the matrix generator solves this by sort of automating all that process. So it's reduced to a export and import. So FMR's existing user interface doesn't go anywhere. It's still got very, very valuable use cases, but it's augmented with a second user interface specifically for data modeling. So use cases for the main FMR user interface remain as they are, no change there, but a brand new, a completely decoupled user interface specifically in support of this statistical data modeling workflow. Both completely connected to the FMR metadata engine, so completely seamless workflow from that respect. So who's the audience for this? Well, kind of not surprisingly, is data modelers, I guess, and particularly data modelers and statisticians involved with modeling complete domains. So particularly what do we mean by that? Well, obviously we mean things like labour and demographics and national accounts and so on and so forth. But as I say, not only the task of modelling new domains, but also the task of remodelling domains as well. Generally, obviously, these things are characterized by multiple data flows, multiple DSDs. So, if you're just creating sort of one DSD or one data flow, then maybe not quite so useful. But if you have got multiple data flows, multiple DSDs, and critically with a harmonized set of concepts. So your domain has a harmonized set of concepts, but they're reused by the data flows and DSDs within that. So if you're familiar, obviously, with the matrix generator and everything, you'll also be familiar with this. So really no change there. So one question which is often asked is, does it work with Workbench? So again, thank you to Jose this morning for his nice presentation on Workbench. Just to recap, if you haven't come across this before and sort of not completely familiar with the distinctions, this is a really good opportunity to sort of make this distinction. So Fusion Metadata Registry and Workbench, or Fusion Metadata Registry, Workbench are two separate tools. Fusion Metadata Registry comes with its own metadata repository. So if you put artifacts in it, it's stored within its own metadata repository. You can get them in and out. This is how the global registry works. So no surprise to everyone there. Where Workbench differs is that it's basically all of FMR, but without the repository. And in fact, what it does is it uses distributed repositories. And a distributed repository is any repository that exposes an STMX-compliant structure REST API. So any repository which exposes us workbench can work with. So obviously this works very nicely in tandem with .stat. Again, as Jose presented this morning. So each space in .stat presents itself as a metadata repository, and you can set those up in workbench. So the answer is yes. The intention is that it works with both native FMR and FMR workbench, such that using the data modeling UI in the workbench, constructing your model using the DSD matrix, pressing that commit button will materialize the artifacts directly into the space or into the metadata environment which is you're currently connected to. Okay, so let's do just a little bit of a deep dive. So we have some sort of wireframes which have been created for this. We'll have a look at a few. If you look at these, give you an idea about sort of what's envisaged. These are not in any way sort of screenshots or anything. These are just sort of fairly low resolution wireframes just at the moment. So the main feature here is the DSD matrix. I'm not going to go into sort of too much detail about this, but fundamentally it's exactly the same as principle as it works in the current matrix generator, to the extent then that it's a two-dimensional table, concepts along the top, data flows and DSDs down the rows, and then the task is to define the cohesive list of concepts for the domain, and then map those to both to the data flows and then to a suitable subset of DSDs following the optimization guidance actually in the model. And in addition, you can also define constraints. So the sort of the glyphs in the cells, if you like, there you see sort of hashes and underscores, ZZs and things to define the constraints for those particular kind of concepts within the context of those data flows. So again, I'm not going to go into sort of any sort of massive detail in this, but I think probably the takeaway is that the envisaged principle here is that it works in pretty much the same way as the matrix generator. So decomposition 2. So I think you've already spotted there's sort of two tabs in here. One called sort of matrix, one called decompose. So again, no detail on the decompose. I'm not going to steal the thunder from the next presentation, but I think again the message here is that yes, it'll support both the matrix modeling and the decomposition step as well. Right, so here's the business end of it, materializing the artifacts. So the process of modeling is very iterative, an optimization process. So we assume that's been done. You've got to the state where you're happy with your abstract model. You've got a matrix, you've got a bunch of concepts, you've got a bunch of DSDs. You're happy with the data structure definitions that are actually defined there. You've got your constraints in place. All's good. So we're now to the point where you can actually materialize these things as SDMX artifacts. So said a bit earlier, there's kind of a commit button here as such, and pressing that materializes directly into the FMR, or if you're using Workbench, into the repository, the actual environment or the space that Workbench is connected to. So quite a straightforward, quite a seamless workflow. Directly equivalent to the matrix generator's generate step. So kind of the difference here, I think, is obviously when you're working with a matrix generator, of course, you press the generate button, it's just going to generate some new files. That's fine. That works nicely. But obviously when you're working with an existing metadata repository, more often than not, it's already going to have some metadata in it. And particularly, of course, if you have created a model and materialized as SDMX artifacts, you want to make some changes. There's going to be this addition cycle, isn't there? So what happens then? So specifically, we envision some logic here to handle both the creation of completely new set of artifacts, but also update of existing artifacts. So if perhaps you've reused a code list or something like that, and you've added some new codes to it, then of course what you'd like to do when you materialize those is not, you know, create a new artifact, but you want to merge those codes in. So certainly that update scenario is envisaged. But further, it's useful to understand the impact of your changes. So if you are following this remodeling exercise here, where you already have an existing DSD matrix, you press the button to create your artifacts, and then you want to make some changes and do that again, then it's helpful to understand the impact of that. And what's envisaged here is sort of like a Git style diff function or some form in order to visualize the changes and see what you're actually doing, because obviously you don't want to potentially make sort of destructive changes which could otherwise be the case. So just including this completely equivalent to the matrix generator generate step, but because it's directly connected to the repository, there's some extra logic to help with that workflow, and particularly with updates. So with the matrix generator, a matrix is a workbook, an Excel workbook, and that's actually quite convenient in many respects, because it can be stored on the disk drive, it can be emailed, you could do lots of cool things with it, as you would do with any Excel sheet. But what happens in this particular case? Where do these things go? Where are they stored? Well, there are kind of two options here. One is actually to serialize the matrix as you have developed it as a file, and that probably won't be Excel, it'll probably be something like JSON. But the other option is we actually manage and materialize it as an SDMX custom structure artifact. So custom structures, if I remember rightly, is something which is being worked on by the technical working group, which allows SDMX structures, custom SDMX structures to be defined. So it could do that. But anyway, irrespective, the point here is that it might be actually useful to actually store and manage matrices, DSD matrices, as complete abstract domain models, as their own SDMX metadata artifacts. And the image there is sort of like a mock-up of how it could work. So, you know, you could see that actually as an artifact within FMR. So this may or may not be useful. You know, one envisaged use case for this is actually sort of publishing complete reference domain models on something like the Global Registry or somewhere else, so that statisticians who are interested in developing their own models can take this and perhaps work with that as a DSD matrix, and then materialize their own domain models out of that. So, right, coming towards the conclusion. So where are we with the project? So we started largely around the beginning of the year with this, so quite a lot of work has been done on the requirements engineering, concept design, as we've seen, scope, cost estimation, etc. And really the next focus here is very much threefold. It's about validating this vision, and this is part of what we're doing today, starting to replay it back to everyone to say, what do you think? It's really helpful also to have a concrete use case in order to develop this again. So nothing's been developed yet beyond the wireframes, so it's really helpful for an institution to come with a concrete use case in order to actually develop an MVP solution against. So that would be really helpful. And third, by no means least, funding. secure funding. Everyone's laughing. To actually complete the builds, and subject to that, so the deliverable out of that is an MVP, minimum viable product, which is taking the wireframes and developing those into the complete web user interface, modern technology, first prototyping, feedback. Obviously, a feedback loop as within the user interface. It's driven by the users. So this developer prototype, several rounds of user feedback are really important, and then delivery of an MVP. Plenty of stuff on the backlog. We had a really good requirements gathering workshop in the spring, and there are many very innovative things on the backlog there, including things like collaboration, team collaboration, and AI, and lots of other things. But this is about the MVP. This is about getting it working. Okay, so here's the ask then. So. Request for comment. First and foremost, is there demand? Or is everyone happy with the matrix generator? Is the value of this sort of integrating it more closely directly with the repositories? Is there value in doing that? So feedback on that would be really useful. Any key features missing? Obviously, I've only sort of highlighted today the very key features of that. Anything that's missing, anything that's a must-have, really helpful to know. Concrete use case I've already explained. So. Any institutions with a concrete domain modelling use case or remodelling use case, very interested to hear from you from that. And again, investors invited to co-invest in it. So I'm going to conclude and wrap up now. Final thing to say, just sincere thanks actually to our OECD colleagues and National Bank of Belgium for participating in this. There's been obviously a lot of guidance in this and participation in the requirements and concept design stage to get to this point. So just a call out to those, thanks very much indeed, really helpful. It's allowed us to get to where we are for the moment. That's all. Thank you very much. I'll close for there.
Thank you, Glenn. Actually, we can take a couple of questions if there are some in the room. Dania.
Technology is cool, especially when it works. Thank you, Glenn, a lot. I'm sitting by chance next to David, and we had a few vintage moments, looking at this concept of modeling through the matrix, and then what happened with the matrix generator and so on is still appreciated, and I think it's super welcome that it will be part of FMR. There's just also another question, maybe not directly related, but what I get a lot from the data modelers I work with, which very often are outside of our community, right? To say it's like, okay, they use other data modeling tools, like Draw.io is used, or Oracle Data Modeler is used, and so on, where they have like their graphical models, and then this needs to be translated to the matrix. So we need to take the entities and we need to fill out the matrix and STMXify it. So one idea that is spinning in my head since a year or so is to maybe have STMX plugins for those existing graphical modeling tools, where we pick up people that do pure data modeling, and then we can STMXify it and implement it without them even needing to dive into our world, let's say, which they would still need to do if they use the matrix approach. I think these things can coexist, so I think very much welcome that the FMR has that, but maybe there is also in the room kind of some thought of maybe looking at some existing free or open source tools that are widely used for data modeling, and where can we inject STMX in those. And that would be super cool also to sell it outside of our community and to bring more data sets into STMX, just as an idea on top, let's say.
Yeah, thanks. I mean, a really interesting point, and I think it's, yeah, I mean, this has been thought about before. It's quite tough though, but yeah, for sure. I mean, you know, sort of many data engineers are sort of familiar with graphical modelling tools for relational models. You know, you can go and draw your tables and put your relations in and things, and I think that works really well. And actually, Draw.io is quite a good innovation here as well. So thanks. Yeah. Let's stick it on the backlog, see where others come from. Such obviously it's sort of slightly different, perhaps from the sort of the matrix generator model, but let's stick it there and see where we go with it. But it's definitely something we can do, and maybe it's a good application for AI as well. So you know, sort of an AI sort of introspection of a Draw.io model. You know, sort of an AI converting a Draw.io model, you know, diagram into model. That'd be really cool. So, yeah, thank you.
Luca, yes.
So just a couple of comments. So in Eurostat, we are great fans of the SDMX matrix generator, so we use it a lot. And the great advantage that it has for us, besides the fact that it's fairly easy to use, it's also that it allows us to share information about the DSD with statisticians in a format that they're more or less comfortable with. So it's also a great collaboration tool with the statistician. You know, you send them the matrix, as long as they understand more or less how it's organized. They can look at the code list, they can say, here it's wrong, they can put a comment, they can add another one. So that is a great advantage, and that might be a bit more difficult to translate to an interface like the one you're thinking about, simply because, you know, it's a new interface, it's a bit less intuitive maybe, but so that might be a challenge maybe. But one difficulty that we have with the matrix generator, on the other hand, is keeping it, let's say, aligned with what we have in the registry, because then, you know, we make the matrix, we do it once, we put it on the FMR, and then we need to, 1 month later, we need to add one code. It's easier to just do it in the FMR and not represent it in the Excel matrix, and then it becomes misaligned, and then it can be solved through good document management, but yeah, we don't often have good document management, and that would be a real selling point. So I don't know, this is just a quick reaction on maybe pros and cons or things to take a look at of this integration. And in terms of, let's say, development or co-financing or co-development, I mean, we can maybe speak a bit bilaterally afterwards on this. Thanks.
Yeah, perfect. Thanks, Luca. Yes, Raphael, please.
Maybe just a quick follow-up on Luca's comment. For the FMR, we have this Excel export import, and we use this quite often actually for collaboration purposes. Yeah. In your workshops, I thought it was also discussed to have an Excel export and import, which would then somehow, you know, help you a bit, yeah, because it's.
You do have the Excel import-export, but it doesn't quite fit with the. It doesn't quite fit with the matrix generator. So then, and also the matrix generator has an import functionality. You can read a DSD and import it, but also there are some limitations, especially I think if the DSD is inheriting from multiple concept schemes, then it doesn't really work. So I mean,
I think David begs to differ.
But I mean, it's it does work, but it still requires a bit of you know, manual fine tuning, I would say.
No, exactly. I mean, because I think what you don't want to rebuild is like a flexibility as you have in Excel in the new solution. Yeah, that would be really an overhead. I mean, all the collaboration functions with annotations, chain tracks, and so on. Yeah, you don't want to include that there. So I think it's probably somewhere a balance which you need to find. Yeah, but thanks, Luca.
Yeah, precisely. I mean, this must not be a step back. In fact, I was talking to David earlier, and I think we both agreed that this doesn't necessarily completely replace the matrix generator. Matrix generator potentially still has a role, particularly in places like developing countries, for which obviously it's just so simple to use, But the whole collaboration piece, I think there's a balance between sort of collaboration and sort of exchange, and then the metadata governance as well. So obviously, as I explained, if the models are then stored as metadata artifacts in their own right in the registry, then they can become part of that metadata governance process in precisely the same way. And I think this problem, Luca, that you mentioned, which is actually the sort of disconnected nature that the matrices have a life of their own. Completely independent of the structures actually within the registry, and they're very, very difficult to tie up. I think this is one of the key challenges that we're aiming to addressing. I think it does, but the detail is obviously still to be sort of worked out in the next stage.
Okay, thank you very much, Glenn. We can continue expanding on that discussion at the end of the session. There will be a Q&A time allocated. So now we are moving away from the tools that can help us with data modeling and moving now to the conceptual exercise with a presentation by Yavuz and David from OECD. They both have been already on stage, so they don't need introduction. They will be presenting on the composition of indicators to identify statistical concepts. So Yavuz, David, the floor is yours.
Yes, so hello once again, everyone. So yeah, I'm caught between kind of crying with sadness and crying with happiness, because people are saying like nice things and bad things about the matrix generator, which of course is my baby. So yeah, so anyway, I'm not here to talk about that so much. So this is a presentation on the decomposition of indicators to identify statistical concepts. But I think it's a bit more than that, really, the decomposition exercise, because it's more on taking a kind of a legacy data model and finding out the kind of the underlying characteristics in this model and coming up with a better model. Really, it's really the basis on which to continue the modeling exercise. It's really important, and it's a bit more than identifying statistical concepts. It's also about finding out which codes you will need in the rest of the model. And it also leads to the mapping that you may create between your legacy model and the new one as well. So it actually serves several really important aspects. So this is the step-by-step method of structural modeling. So first of all, we start with deciding the scope, which is where we list the data flows of the model. So we saw the diagram that Glenn showed, which was the labor statistics model. So yeah, you identify the data flows, and then you go to this exercise of saying, okay, for all of those data flows, what are the concepts that we will actually require? And this is what we will focus on here, because this allows you to go to the next steps, which is deciding the concept types, defining the code list for those concepts, and then defining the matrix constraints, etc. Oh, thanks, Yabuz. So why does the decomposition exercise matter? So it increases the accessibility and interoperability of the data. Now, if you don't start with a good modeling step to actually, unpack the characteristics of the data. You can still increase accessibility of the data, but you're just kind of, making a kind of fuzzy model more accessible, right? So it doesn't mean to say that it will necessarily be more understandable and interoperable. So when we do this decomposition exercise properly, it's designed so that the data queries can become easier because it's easier to slice the data. It's easier to kind of understand the characteristics. And also, it allows data to be compared, within the context of series. And it's really underpinned by the presentation that Yuri gave on the units of measure. This idea of having a concept which denotes what is being measured and in what way it's being kind of counted, or in what way it's being measured, and increasing the comparability of the series through this kind of submodel. So when we did the remodeling at the OECD, we in all of our models we use the unit of measure model, not because we had to, because we came up with this thing, because it actually came out of going through all of our models and finding out that this was like the best way to do it. So yeah, but just a final point before hand over to Yavuz. I mean, it's always really interesting to do this decomposition step because most of the people who are involved in this, they're not SDMX experts, right? In fact, you have to have most of the expertise in the room there to do with subject matter and the people who understand the series. And when you do it, you actually find out that for some of the series, they're not very well understood, even by the data managers, right? Because they may be coming back to it after a long time, or for some reason it wasn't modeled very well at the start. And you can spend like quite some time actually with them, and they actually came up with these series, and you say, well, what are the underlying characteristics? And then there's a really good discussion like around a table to actually do this. So yeah, and with that, I'll hand over to Yavuz. Thanks.
Thanks a lot, David. Yeah, it's, as David mentioned, it's a very crucial step for us for the remodeling exercises. If it's not done properly, the later steps on the remodeling exercise can fail, or even you need to back and forth for the several times to see the different approach as well. And in OECD, we usually insist on to kind of especially kind of concentrate on the correct approach, and then later design the model and other STMX artifacts, as well as the mappings according to the decomposition part. It's a very essential step for us. And at the beginning of the modeling exercise, it was quite complicated with the data managers, as David mentioned, and we were struggling to really understand what was the actual kind of measurement plan in the background. We were kind of digging into referential metadata or trying to find someone who actually set up this kind of measurement, and then it was quite complicated even for us. Imagine the end users, how they were suffering in the background for the discovering the data. This is from our legacy application, but right now we just archived all the data sets, and the name of the data flow, main science and technology indicators, and it's compendium style. Very straightforward model, just only one country dimension and then time period, as well as the MSTI variables called, and then more than 100 indicators listed in the same place. As you can see, their concepts are merged into or just bounded into just only the one indicator actually. I mean, the main motivation from our side to highlight to the data manager to saying that, okay, how can I select, or imagine I'm a kind of a researcher and I would like to see all the figures related with the percentage of GDP. What will be the best way? Should I, even in the old platform, the search was not working properly, and then I will go select from the top 1 or 2, and then the rest will also continue in such a way. I mean, it's not a good way, and then very time consuming actually at the same time. We start identifying firstly the core measure, and then the other components, other concepts, candidate concepts like a unit of measure. Like as you can see, we have the current PPPs, and also we have some constant price figures as well, how these items should be measured and then represented in a well-tuned table model, actually. I mean, after this discussion with the data managers, at the same time, we need to just feed some kind of a technical background for this decomposition exercise, and then we just need to highlight to deriving the logical concepts of the model by decomposing the underlying definition of each indicator is very essential for the new dissemination platform. And also unpacking the orthogonal characteristics in each indicator into the standalone concepts allow us to manage the common artifacts, and even from in the decomposition part for the several different projects, we realize that okay, there are some kind of new candidates for the common concepts as well as the common code list as well. I mean, it was unbelievable before just putting everything to the dissemination platform and then see 2 different structures. And then thanks to this decomposition approach, we well advanced to this kind of requirement. And another part actually, in the legacy application, we have several variations like series, indicator, subject, variable, and some others as well. But in the new platform, we decided to just select one item, which will represent the other variation as well, and which is called measure, actually. So, as David mentioned, each data flow or data structures has the measure concept as well as the corresponding unit of measure items. Of course, we are following the guidelines as well as our code lists and to drive the new unit of measure items. And yeah, we just basically trying to build and reuse the commonly shared artifacts, concepts, and then the code list as well. And then in addition to the common and harmonized artifacts, we are using some standard breakdown concepts based on the STMX cross-domain code list, like unit multiplier, observation status, confidentiality status, and then the others. Again, I just would like to show a couple of decomposition exercise from our legacy application across the different domains. And again, it's coming from the main science and technology indicators. The variable called like a basic research expenditure as a percentage of GDP. I mean, for us, the basic research expenditure, the core measure actually. I mean, we're basically measuring the basic research expenditure, but the percentage of GDP should be defined or derived for the unit of measure. In that case, it's a dimension actually, but it could be an attribute for some other case. If we continue this exercise by row by row or indicator by indicator, we realize that we have the other concepts like an unit multiplier, price base, and then a transformation for the growth rates, and price base for the constant or current prices, and also for the national currencies or the US dollar or euro figures. We may need to have the unit multiplier as well. The second case is coming from the economical statistics, purchasing power parities. In the legacy application, we have one indicator which is called nominal expenditure in national currency, and then it was repeating 12 times with the several variations like real expenditure in national currency, real expenditure in US dollar, PPP converted, and there was so much variation actually. I mean, for us, again, the nominal expenditure is the actual measure, and then the national currency is the one item in the unit of measure, actually, and then the millions in the label should be stored in the dedicated concept, which will be the CL unit multiplier as well. And the last example from the earnings database, and the existing indicators says something like a current prices in NCU, and I mean, it was once we saw this part and then we were discussing, I mean, I'm not familiar with the NCU usage, but it was saying that, okay, national currency unit, but it's not clear whether it's earnings, wage, salaries, or something else, and then we would like to firstly to introduce the proper measure items for these ones, and then the first three case, these are the wages, and then the rest for these are we just basically measuring the gender wage gap and then the dedicated unit of measure. For the first two cases, yeah, no anymore we are allowing to NCU, and then in the unit of measure code list we have properly defined national currency. And for the last case, it's obvious even from the definition, it's USD PPP converted. And for the gender wage gap, and we just try to follow the practices in the unit of measure guidelines and drive one unit of measure code list for this part. So the other parts also coming. For the first one, and in the definition or existing indicator, we have the current price information, and then we introduce the price-based information. For the second and third case, these are the constant prices. And we have one concept which is called statistical operation, because I mean, it's not obvious even in the existing indicators, but somewhere in the data flow or data set name or somewhere in the referential metadata, these are actually the mean wages or average wages, actually. And it's worth to mention this information in the table view to just save the end user's life a little bit, or provide some kind of insight about the actual data. And then for the different variation of the gender gap, we are using decile 1, median, and then decile 9. And then for the constant prices, we always associate with the base period information. In that case, it's 2020, sorry. Well, for the conclusions, actually, I mean, we apply the composition of the indicators for the several domains in OECD, and I mean, in total, it's almost 1,000 different data flows, and we try to do this approach for the most of the cases. And some cases or some structures already aware of this problem. They just kind of follow the practices in advance, but some cases we need to also review them one more time and then try to harmonize them as well. And also, as I said in the beginning of the presentation, it's very essential for the STMX artifact maintenance, and then for the code list concepts. And in the decomposition exercises, we have realized that some new breakdowns of for example, for age code lists and others. Our central team knows that, okay, we finalized, but this item is not covered yet, and let's do a request and then inform the data managers and then start kind of a fast tracking maintenance role, and it's very essential. And we also, under the SIICC collaboration community, we assist some other agencies for the implementation. Maybe you would like to say something about, you have some recent experience with the different organizations? And
well, just to say, yeah, I mean, I went on mission to other agencies, and I used exactly the same approach. So, and it seemed quite valid as well. So, the approach scales quite well. There's a lot of interest in it, and we managed to kind of remodel a whole database, in I think a day, in one case. So. It seems to be not just applicable for the OECD by any means, and it's based on the data modeling guidelines. So, yeah.
The question to the community, do you think there are any barriers to adopt similar approach for the other domains? I mean, that was our first kind of question to bring into your discussion, and also for the microdata modeling. And then first day we had a lot of discussion about the microdata modeling and then the requirement from the STMX 3.0. Even in our cases, we already disseminated some microdata in the new dissemination platform, but for the decomposition part, actually we didn't too much kind of exercises, and we tried to stick to what the tool offers and how the structures are remodeled. But yeah, that will be, we believe that that will be also another discussion point with the stakeholders.
Can I just, and I think, so this decomposition step, which can take quite some time as well, you know, especially if you've got like a compendium of like 1,000 indicators or something, I think this could be quite a good target for artificial intelligence, you know. So if somehow you can point, you know, I'm no specialist in this at all, but if you can somehow say, here's a list of indicators, you know, so have a first crack coming up with a kind of decomposition of them, and then you know probably then we'll take it from there. But yeah, I think this could be a very useful approach.
Thank you, Yavuz. Thank you, David. We have time for a few questions. Is there any question? Matthews first, Edgardo, and Lucas, and Abdullah. Here first. Thank you.
Yeah, I can confirm for the microdata modeling, I think there are similar challenges. Like example would be you have not just classification or code list, you know, elements, but also the combination of code list elements kind of hard coded into the variable names and stuff like that.
Okay. Thank you.
Luca next, and then Edgardo.
So one of the issues that we face when we try to go for the same decomposed approach that you implemented is simply that we tend to create then data structure that are more sparse, and then our statisticians don't like this, and it might be more of an issue with our data visualization tool, which really shows data as a cube, and therefore if the units and the measures, as in your example, don't create a sparse structure, it doesn't look good. Now, I'm not familiar enough, to be honest, with the .stat implementation you're using to know how it solves this or whether it does. But I mean, how have you faced issues with sparse data models? And if not, how did you solve this problem that can occur when you decompose an indicator?
Take it? Yep. Maybe you want to say something. Yeah, just one thing about the approach is that we always recommend that when you're doing the decomposition, to actually don't ask yourself too many questions on should I decompose or not. You should just do it, right? So, you know, you take like an indicator and you say, okay, let me kind of like split out all the characteristics of it, and I'll do that for the whole model. And then it's like later on in the modeling process, you may say, okay, well, I've got a lot of sparsity here, and then you can actually put things back together. But you can put things back together, meaning like you can re-merge the concepts, but you can actually do it in a cleaner way than what they were done already. You know, so like Yavuz showed how there was a list of indicators in the same data set which called like, I don't know, percentage of GDP in like several different ways, several different labels. So, you know, you could, and if that's the case, you could like decompose them, and then when you kind of put them back together, you've actually got like a clean way or a consistent way that they're actually modeled, you know, but you kind of lose the sparsity if you need to, you know. Well, I mean, I guess it just depends how much sparsity you have in your data cube. But I mean, usually if you have more dimensions, then you increase the perhaps accessibility or at least being able to like slice the data. Okay, but you're going to get more sparsity, right? Almost always. So it's like a balancing act between, like how much sparsity can I get before it becomes like a problem, and I have to kind of remerge.
Okay, let's go with Edgardo and then Abdullah, and then we move to the next presentation.
Just one thing I would like to add to Luca's question. On the dissemination part on the table, we have an annotation which allow us to combining concepts in the table visualization as a virtually. So we just split the measure and unit of measure, but in the table visualization we can merge them back in the same kind of an axis, and which is kind of basically allowing us to overcome this sparsity actually. Yes. Yes.
Yeah. Okay. Yeah. It's actually a standard annotation called combined concepts, and we use it like all over the place in .stat because it allows you to kind of put unit of measure and unit multiplier together, and but you can actually use whatever you want. You can put like age and sex together if you want in the same label. So.
Yeah, I couldn't see all the presentation, so maybe you already said what I'm about to say because I had to take a phone call. But for me, there are an important caveat in this process that has to do with coin terms. And for example, you were asking other domains. In labor statistics, if I dare to decompose unemployment rate to become unemployment expressed in percentage, I would be fired. If I try to change female share or whatever into the indicator with sex equal F, nobody would understand. So I think that, yes, the decomposition is important. It makes a lot of sense in some of the examples, but it has to be balanced with the domain established terminology. And that's one point. Regarding microdata, I think that for microdata modeling, I can imagine that, yes, there will be cases, like Matthias said, that it will be the same, but there will be others that will be the opposite, in which you will probably process raw data and compose a variable that is easier to process. Typical example, the sequence of questions that convert into a categorical variable, so that what I try to say is that I think that is a different modeling world that we will have to learn about.
So yeah, I can remember the conversations about unemployment rate in the global labour for DSD some time ago. But yeah, for things like coined terms, this doesn't kind of really touch on what to do about those, right? If you have constraints on how you have to disseminate your data, then this is almost like another conversation. If you absolutely can't, for like legal terms or whatever, decompose something, then you can't. Okay. Then on the microdata part of this, it's something good to discuss now, but we haven't really kind of investigated that, as part of this. The unit of measure, the question was asked about that earlier on, but I think that this is like probably like another step. See how we do that from here. But I think Yuri may want to add to my point. Is that okay?
I think we're probably out of time. We do need to move to the last presentation, so.
I'll be going short. Yeah, I'll go short.
Okay, so he's busting to say something.
Thank you.
I've probably said something wrong. He's going to tell me off.
No. I totally agree. What I just wanted to say. Sorry, I forgot what
Yeah, I mean, support what Edgardo said. I don't think we need to talk more about coin terms. But one issue I can see here is that if you do have some of these very well-established indicators, then they may cause issues because they wouldn't be, I mean, they might have dimensions collapsed, which would have been decomposed in other similar indicators of similar nature, and that might create inconsistencies. So, I mean, what I'm trying to say is that I generally support this approach. I think that this is the proper thing to do, and most of the time it should be followed. But there could be constraints. I think it works for dissemination. It's more difficult to make it work for reporting because things like coin terms, they are more important in the reporting context. But something else which I was thinking about, I feel that if you take the composition to the extreme, then that might make the data more difficult to interpret. Because if you take, well, let's say the World Bank indicator, per capita GNI at purchasing power parity. If you decompose it, if you put this into 4 or 5 dimensions, then a lot of people, probably myself included, would have to look into those 5 dimensions to try to figure out what really is this exactly. Mm-hmm. What's your indicator? Is it GDP as in national accounts? Or is it per capita GDP? And where's the purchasing power parity adjustment? Does it go into the unit of measure? You see, an indicator, when you read this, you know how to interpret it. If you take decomposition to the extreme, it might be difficult to understand, to interpret properly. Thanks.
Okay, so yeah, just final response. So I mean, so a couple of things. I mean, when you're in the remodeling project, I guess this is the time to actually reconsider your coin terms, right? I mean, when else are you going to do it? So if you should decompose and get fired, is what you're saying. Yeah. Yeah, decompose, see if you're going to get fired, and then kind of recompose. And then the other thing on the indicators, this is a iterative process, right? So it's not like you decompose and then create your model and then you can't do anything else. It's not a waterfall. If you look in the modeling guidelines, it's very iterative. So it's experimentation. I feel as though you should decompose. With .stat, then decompose, we map the data, we put it up there, we see what it looks like. If it looks crap, if nobody can understand it, then we kind of, remodel and bring things back together. We look at like the sparsity, we look at, are the data managers happy with it, things like that. So we've been very, very successful in the whole of the .stat migration in doing this, I feel. Well, we've done it anyway. So anyway, that's it from me.
Perfect. Yeah, really dynamic debate. So in that case, David, Yavuz, thank you very much indeed. Thank you. So the last and final presentation for this session, and I think indeed for today. So this is presented by Alan Boddy on the topic of semantic versioning. So Alan is a Senior Data Management Officer at the IMF and also an active member of the Technical Working Group. Alan, thank you.
Okay, so thank you. I'll go quick as I promised. So. Why am I here? To talk about semantic versioning? Well, there's already a guideline that was produced in 2015, but a lot has changed with STMX 3.0, right? We have now more encouragement to use semantic versioning. We have 3-digit versions. We have wildcard referencing, which I'm not exactly sure how you could use if you were not using semantic versioning, sort of in most cases at least. So, there's a real need to update these guidelines to reflect the changes in the standard. So we decided to have a cross working group task force on STMX versioning to update these guidelines. And the goal is to sort of expand what's there. We'd like to show for every maintainable artifact how each action you could do to it should impact the versioning, a code list adding a term, would be a minor change. Removing a term would be a major change, sort of things like this. So to just articulate what every sort of action would do. And we'd also like to document best practices around wildcarding. When should you have major wildcarding? What are the dangers in certain situations of having major wildcarding, et cetera. We've decided to collect all this as a series of markdown files, so hopefully it's easy to keep up to date as we move forward, easy to reference specific pieces of the guidelines. Okay. So just a quick shout out to our membership. I've taken a lot of their time to go over these, have lots of conversations around all these concepts. And when we're saying that we're really going through every artifact and all of the actions you could do to it, I mean it, like concept scheme, a concept you can modify. It's a concept has something called an ISO concept reference, which you may know if you really know the SDMX standard, but I had no idea until I looked into this. So, we have conversations like, well, is that really, should we treat that as a metadata field? So if you change it, maybe it should just be a patch? Or should we say, well, if you're changing the ISO concept reference, really you're changing the concept, fundamentally what it means to be, so should it be a major version change? So these are the sort of conversations that we've been having as a group. And here's a sort of sample of our documentation. Unfortunately, so I could try to make it readable on a small screen, I picked like the easiest object there could possibly be, right? The data flow. But the idea is, a section on the actions that you can do, and another section at the bottom on the various places that you can have wildcarding from within this thing, and then what you should consider if you're wildcarding at the minor level or the major level. And while it's not obvious here, one thing that we've tried to do is for every action, we tried to provide a comment on why this would be a major or minor change. If it's just a patch, no explanation needed. But if it's more than a patch, we try to provide some reasoning behind that to help people understand this. Okay. So our progress. So originally, when I sent out the terms of reference, I said, this will be great. We'll be done by the experts workshop, and we can release it and say, job well done. But unfortunately, we're a little bit behind because conversations have been, so detailed, so well. But we have gone through most of the major artifacts that you'd recognize, so that's good. Sort of the basic objects, but we still have a bunch more to do. The good news is, sort of, once you've done one sort of schema, all the other sort of schemas you want to treat them quite similarly. So while there are still, 20 or so artifacts that are not listed here, we hope to go through those fairly quickly. Okay. As part of reviewing basically everything as we've gone through to figure out what should the wildcarding be, what should the actions sort of affect the version number. We've come up with some recommendations that we intend to include in the standard, or at least intend to send to the technical working group. Most of these will go for SDMX 3.2, and these are just the ones that we found so far. Keep going through the remaining artifacts and probably have some more. Of course, this will be reviewed. And then for 3.1, there was one small one that I believe did make into to what's gone out for public comment. So our next steps, we plan to release the new version of the guidelines next year, early next year. 2 versions, one for SDMX 3.0, and then one reflecting what's been changed in 3.1, so we can really tie it to the version. And then going forward, once these have been publicly reviewed and people are generally happy with our recommendations, what we want to do is include it formally as part of the SDMX technical specifications, so that whenever there's a new release of SDMX, these can be updated along with the release. Because whenever we make a change to the artifact, we need to have the guidance on, how should those changes impact the semantic versioning. So that's where we are in our next steps. So I told you I'd keep it quick. If there's any questions or any comments, happy to answer.
Abdullah, please.
Yeah, thanks very much, Alan. Two questions, or maybe it's even a single question. Do you provide any recommendations for transitioning from SDMX 2.1 style versioning to smart versioning? And do you provide any recommendations on how in this environment to deal with these final attributes? Because I find that very annoying, to be honest.
Yeah, so as part of our scope, we definitely did want to provide guidance on, how to use drafts. So also the mirror of that, how to deal with final artifacts. So yes, I would say that that's part of it. At least I had not considered including guidance on how to transition to semantic versioning, but I think that that's a really good thing to add and something that we should add.
No, the reason I'm asking is that people are working with, they're working with SDMX 2.1. They're using FMR. FMR no longer has editable is final attribute. How semantic versioning is going to work, it's not going to work in 2.1 as designed, that's for sure. But is there any techniques that you can use with regard to semantic versioning in SDMX 2.1? How do you manage this? How do you manage this transition? I get those questions a lot, and I'm not always sure how to answer them. Thanks.
Yeah, no, I think that's a really good point. I also don't know how to answer them, other than, the is final has the analogous of, draft extension, but beyond that, I think it's something that we need to think about.
Thank you, Abdullah. Any more questions for Alan? No questions. In that case, Alan, one question. Matt.
Maybe just a general comment on top of what Abdullah said, which is when you use semantic versioning, you cannot reference something that does not use semantic versioning. Right? So if you've got a data structure definition that wants to use semantic versioning, you cannot use concepts or code lists that don't. So it's an interesting question on transitioning, of course, with things in the global registry and artifacts people may want to reuse, because it's almost got to be done as a package. Right? All the base layer needs to be transitioned before you can actually start to make use of that at a higher level. So a comment rather than a question.
Thank you. So no more questions. See no hands. In that case, Alan, thank you.
Okay. Thank you.
So in the remaining 5 minutes or so, we have, skillfully prepared by Yamil, a couple of live poll questions on the subject of data modeling.
Just two quick questions in Slido to get your views on this. Okay. Which tool have you used for data modeling in SDMX? Select all that apply. Let's see a quick poll on this. Also, if you select other and the other is not listed there, it's the toolkit or ODP 2.0, and if you want to share with the group, what is that other tool that you use? Notepad. That would be awesome. Notepad. It's a good one. Blackboards, spreadsheets. Okay, very good, 65% FMR, SDMX matrix generator, Davey, your baby.
It's widely used. Okay. Very good. Let's see quickly the next one. In your opinion, what is missing to facilitate data modeling in SDMX? Ranking order of importance to you. This will help the governance bodies make informed decisions on where to invest resources to help implementation of SDMX. Guidelines. David, this is another baby of you, guidelines of the statistical working group. This is okay. Maybe the modeling guidelines need some updates. Actually, on capacity building, something that someone asked me to remind the group in case the capacity building came on top, is that there are a few resources available for data modeling, learning resources, and if you go to sdmx.org, the learning section on sdmx.org has been revamped. It's nice, nice update, and you can now filter by topics. And if you filter by data modeling, you will see is probably the topic that is more covered. There are a bunch of resources, but yeah, maybe it's a matter of advertising this a little bit better, or something is missing here that will facilitate. On the capacity building on data modeling in SDMX. Very good. So that's from our side, but I don't know if there are any other final remarks or questions for any of the presenters. Yes.
Okay. Yeah, thanks. So I think it goes a little bit beyond data modeling, but I was thinking about that other option, right? I think something that we struggled a lot when starting with SDMX is trying to go from start to finish, having a full workflow and some examples that we can leverage from scratch, right? Because we started trying to do modeling without the tooling to actually publish SDMX data, so we couldn't see the results of our remodeling. What does it mean on the front end, on the dissemination side? A lot of the SDMX data we generated at the beginning were wrong, so didn't pass validation. Having some examples out of the box, okay, this is the original data, this is what happens once remodeled, this is what happened once you disseminate it, and you can use as example and work from there to your actual data to see what is the gap and where you're failing. I think that would be very helpful. I think it's there somewhat in the DotStat Academy, in the data modeling courses. Mm-hmm. But yeah, there are some missing pieces, I guess.
Very good.
Thanks.
Good note. Yes, Brian, and then Q. Oh, I guess, yeah, you go after.
So I think, if I'm not wrong, there is something is missed, or maybe we have to take in consideration. When we start data modeling, is the purpose of the data modeling, because this will impact the number of dimensions, especially when we have data collection. So we have to maximize to avoid that we have many DSD, but in the context of dissemination, we have to think about how to have the right balance. I know maybe in some tools that we have the possibility, like exposed by our colleagues, and very fantastic functionality to merge or to concat two-dimensional attributes together. But I think this kind of purpose of data modeling should be taken into consideration when we start to make the right balance and to optimize the decision. Thank you.
Very good. I guess this is related to the decomposing of statistical concepts. Okay. Thank you.
Just a very quick clarification question for Glenn. So my assumption for the advanced data modeling tooling in FMR is that that would be fully SDMX3 compliant, yes?
Yeah, of course. Yeah, I mean that's certainly on the roadmap. Whether the MVP is SDMX3 compliant, by that I presume you mean the multi-dimension, the multi-value attributes and everything. Yeah, so for sure, I think obviously sort of moving it beyond the traditional sort of aggregate time series and into the microdata world envisaged by SDMX3 is pretty critical. So, yeah, maybe not for the MVP, but certainly on the roadmap.
Just before we close, I just want to give an opportunity to Davey, Yabuz, or Yuri to comment on Kamel's point on the decomposition of a statistical concept when it's for dissemination. So, I don't know, guys. Any comments on that? No? Okay, well, Edgardo, please.
Just one comment. I am surprised that in the whole session about data modeling, we were not talking about the difference between data reporting or data exchange and data dissemination. That I think there is a difference, and you have to have that in mind when you start doing the modeling. So it's just that we have that so clear that we don't even need to mention it, or am I right? Am I wrong?
It's so clear. It's part of the guidelines. It's so clear.
Okay. Good.
All right. Well, Glenn, if you want to take us to the finish line, please.
Okay, I'm not sure there's very much else to say other than thank you very much indeed. I think it's a really dynamic session. Thank you to all the presenters. Thank you all to all of the questions as well. Very dynamic discussion about decomposition, which generated quite a lot of debate, and I'm sure it will go forward. So nothing else to say. I think that we're at the end of the day. Thank you very much indeed. Have a great day.
All right, before you all go, just a couple of words, organizational announcements. So, the dinner for tonight is going to be at a restaurant called De Vijf Vliegen, which I understand means 5 flies. Which is maybe not a great name for a restaurant, but still. I did not know the meaning when we booked it. Huh? So I don't know if you could share the screen. That's it. So you have it written as well on your agenda. So, I mean, you can Google it and see where it is. It is about a 15 to 20 minute walk away from here, if you want to walk. If you want to take the tram number 2 is quite convenient. It goes from this Leidseplein stop to this Koningsplein stop. Or you can be very Dutch and take the bike, which is also the fastest method, apparently, to get there. It will be at 7:30, if I'm not, no. 7:30, yes. 7:30, it's there. So we wait for those of you registered to come there. Now there should be a coffee, hopefully, downstairs as usual. And tomorrow we're going to start again at 9. We have the SDMX SDG working group. which will start at 5. Initially, we had planned to have it downstairs. Because of some connection issue, if Abdullah doesn't mind, we could have it in this room and it would solve the connectivity issues. Okay. Then for those of you who are concerned, at 5 here, it also means that those of you who maybe are not concerned by the SDMX SDG working group, if you can take your stuff before 5, because then the room will be occupied again. All right. Thank you.
That would be a change that's outside of Berkeley Tice, right? It's worse than that. We're not starting until 7:30.